So today myself and my group members will present a topic on trade dryers in pharmaceutical industry. First, allow me to introduce myself and my group members. We are from Group P6 for Unit Operation Lab 2, and my name is NURUL ASYIQIN IBRAHIM, and these are my fellow group members: Austin, HUSNA, Evans, and Omar. However, Omar could not join us today for this session. Trade dryers are important devices in every industry, such as pharmaceutical industry, pulp and paper manufacturing, food processing, cosmetic manufacturing, and also pollution control. Alright, but before that, what is a trade dryer? Okay. A trade dryer is an enclosed insulated chamber in which trays are placed on top of each other in trolleys. Okay, so a trade dryer is used where heating and drying are essential parts of manufacturing process. Move on to the objective. Experimentally, we did this experiment to study the effect of air temperature on drying rate. So we can see how different temperature gives out different drying rate, and also to study the effect of air velocity on the drying rate. So we can see how the speed of air will affect the drying rate. Overall, we did this report to study more on the application of trade dryers in pharmaceutical industries, and also to get more exposure and in-depth explanation on how a pharmaceutical plant works generally. Focusing on pharmaceutical industry, what do trade dryers do in pharmaceutical industry? Trade dryers are used to dry sticky materials, granular mass, and crystalline materials. They are also used to dry plastic substances and wet mass precipitates and also paste before they undergo further process to become a final medication. Trade dryers are also used to dry crude drugs, chemicals, powder and tablet granules, and sometimes even equipment are dried in trade dryers. Alright, moving on to the next subtopic, which is customers' requirements. What do customers expect from a pharmaceutical industry? As you all might already know that pharmaceutical industry produces products that are used in medical sector, that are used for health purposes. So it is crucial for the products of this industry to have this quality. As you can see, safe to be consumed, very high quality, and obey rules and policies. Okay, move on to the customer preference in a trade dryer. What do customers actually want in a trade dryer? First is the design. The design has to be easily operated. It needs to have a faster drying rate so we can save time. You don't want anything that consumes a lot of time. Next is easy hardware and hygiene maintenance so that we can cut the cost of operation. And also we need high quality and better shelf life of the product. Okay, that's all from me. I will pass the presentation to my fellow groupmate. Thank you.
Hey everyone, now I would like to talk about the process flow diagram. There are wide variations in each pharmaceutical plant's process. However, despite the variations, there are similarities that are consistent from plant to plant.
This is a typical process flow diagram of a pharmaceutical plant. It can be generally divided into 4 sections: gathering of raw materials, mixing and reacting, separation, and lastly, final processing, packaging, and shipment. And this is the diagram form of the process flow chart.
Now, we will look into the process flow diagram from section to section. First is the gathering of raw material. The raw material must be gathered to a location such as tank farm within a useful proximity to where the processing will occur. Some examples of raw materials for pharmaceutical industry are ascorbic acid, calcium carbonate, fructose, and sodium benzoate. The second section is the mixing and reacting. Once there is reasonable access to the raw materials are combined and processed. Combining and processing may simply mixing in a mixer or reacting chemically in the reactor. The third section is separation. This step is the important part of the process where the undesired component from the previous step will be separated from the useful components and discarded. The desired components will be moved on to next step. The separation can occur in filter, dryer, centrifuge, or an evaporator. Lastly, the product from separation may be reprocessed to remove additional impurities where it may go through additional mixing and separation steps. After that, it may be stamped into pills as the filler in capsule, become injectable fluid, bottle, or as a raw material for some other processes in some other plants. After final processing into desired form or product, it will be packaged and shipped to other plants as raw material or to be sold to consumers. Now, I would like to explain the equipment list in the pharmaceutical plant. There are several equipment listed below which are important to pharmaceutical manufacturing process. First, we have tank farm and makeup tank. Tank farm is an industrial facility for storage of liquid raw materials. It is normally located near to the processing units like mixer or reactor. While makeup tank make up for the difference in fluid that should be in a pressurized system. The tank will add fluid to keep the system pressurized as desired. Next, we have reactor and crystallizer. Reactor is a vessel where a chemical reaction takes place in an industry. It can be divided into batch or continuous reactor. A typical batch reactor consists of a tank with an agitator and integral heating or cooling system. Continuous reactor can be further divided into continuous serve tank, CSTR, plug flow reactor, PFR, or membrane reactor, and so on. Crystallizer is a vessel where crystallization occurs. Crystallization is the process of formation of solid crystal precipitating from a solution. Lastly, in the separation stage, we have centrifuge and tray dryer. Centrifuge is a device where the process of centrifugation occurs. Centrifugal separation is the process of separating particles from a fluid by centrifugal force acting on the particles. There are a variety of dryers are used for drying process for pharmaceutical industry, such as vacuum dryer, tray dryer, and rotary dryer. However, tray dryer is said to be the best device used in the pharmaceutical industry. Tray dryer is a device used to dry the wet products of the crude drugs, chemical, powders, or the granules. My friend will be explain more on the tray dryer and the experiment. Thank you.
Ladies and gentlemen, I'm going to be presenting to you about tray dryer. Normally, the tray dryer is used in drying granular mass or crystalline materials for pharmaceutical applications. Air is conditioned into the dryer through the air inlet, okay, and then it's circulated around the vacuum after being heated up. The tray dryer is provided with solid, which is supposed to be dried and then put back into the dryer. And then what happens is the air that circulates around has to heat up, and then from there the liquid which is in the solid is being evaporated, and then it has to pass through the upper hole, which is the exhaust. findings after we carried out our experiment. And we divided it into two sub-experiments. There is experiment A and there is experiment B. Experiment A is the effect of air temperature, and then experiment B is the effect of air velocity. Given our results, we have parameters. We altered some of them. For instance, in experiment A, there is a heat controller, which we did not alter, which we basically, alter from point A to point B, from the lower air temperature to higher air temperature. And the rest are kept constant. For instance, the fan controller, the weight of dryer, and the average air velocity. For experiment B, the altered parameters are the fan controller only, from point 1, which is at lower air temperature, to point 2, which is higher air velocity. From lower air velocity. And then the rest are kept constant. What you see is a graph of air temperature. Okay, basically the first part, which is point A, as represented by the line, okay, it has a higher time for the moisture to disappear, basically because the temperature has not been applied. For point B, where the temperature has been increased, okay, it has a lower time for the moisture to disappear. Next, this is basically the moisture content versus the rate. As you can see from the first part, okay, when the air temperature is lower, okay, our graph took a longer time to reach 0 at the drying. Okay, and if you can see from the second one, it took a shorter time, basically because the temperature has been increased, and when you increase the temperature, the rate of the drying is also increased. Next is experiment B, which is the effect of air velocity. The first one, which is at point 1, when we kept the fan control at point 1, which is a lower air velocity, it took a longer time for the moisture to dry. And then for point B, which is point 2 in this case, it took a shorter time because the air velocity has been increased, which increases the rate of the drying and also the rate in which the moisture content has to disappear. Next is the rate of the dryer versus the moisture content. As you can see from the first graph, basically it starts at a point and then the rate increases. Reason being, the air velocity is not increased, it's very low. That's why the drying has to increase. And then it reaches a point whereby it has to decrease again. Basically, the rate of the drying has to increase all the way to 0, but it took a very long time, as opposed to the second graph when we increase the air velocity into a higher point. It starts from a point and then it decreases all the way to 0. Reason being, the air velocity increases the rate of the drying. Next is the discussion part based on the graphs that you have just seen before. Okay, starting from point A, let's see. From point A, as you can see up there, okay, the drying rate increases. This is basically shown to you over here, that part right there. It increases. The reason being, the air velocity is lower, this part. And then it became constant from point B to point C. Okay, it starts from there. It's a bit constant up to some point here, and then it decreases all the way to 0. And then from point C to point D, all the way to point E, which is called the falling rate. Basically, it's given to you by each of these graphs, because at the end of the day, all the drying rate and the moisture content is going to go all the way up to 0. This is all for my part of the experiment, which I talk about the drying rate and experimental findings of this experiment. So thank you very much for listening.
Hello everyone, I am HUSNA and today I would like to tell you about safety measurements of pharmaceutical industry. In order to keep and maintain the plant and the technology as safe as possible, safety measures and precautions need to be taken care of very seriously. Pharmaceutical industry uses a large number of bases, chemicals or specifically organic chemicals in order to produce bulk drugs and drug intermediates. So it is crucial to take remedial measures. Pharmaceutical industry generates quite an amount of hazardous waste. So a standard for regulating emissions from various industries were developed in order to act as a guidelines. Thirdly, workers are often exposed to various hazards from the moving machinery, parts, and equipment and danger from the workplace environment. So a proper personal protective equipment PPE is very important to avoid burns, scalding, inhalation of hazardous gases and more. Now let's move to the safety measurements of the trade dryers itself inside the pharmaceutical industry. There are different types of hazards depending on the type of the plant and the technology used to operate it. Therefore, the most common hazards of drying operations may include, first, dust fire or explosion. Second, release of organic heat transfer fluids and flammable solvents and vapors. Third, discharge of hot product to downstream process or storage. Fourth, fuel explosions, and lastly is sparks, electric friction or electrical. Thus, in order to avoid these hazards to become worse, few safety measurements must be taken care of. First, an appropriate design of the fuel firing control system and application of standard codes of installation will limit the risk from this exposure. Second, to control the potential of overheating, proper understanding of the material properties is needed. Thirdly, hot work exposures are common in this industry, and the hazard can be reduced or prevented by implementing a hot work permit system. Okay guys, now let's move to economic analysis. In general, the growth and the job creating effects of economy are determined when it comes to assessing economic importance. In order to shed light on the contributions to economic growth, some aspects need to be evaluated. All plausible economic indicators of this industry are: first, gross value added; second, the production value; third, the job creation; and lastly, the compensation of employees. The growth of pharmaceutical becomes clearer when the annual growth rates are positive throughout the year, but are quite different over the time. For example, in this graph, besides, in the year 2012, it indicates the largest increase in employment with a growth rate of 4.9%. Besides the measurement of the growth and job-creating effects of the pharmaceutical industry, the sector-specific production value and the compensation of employees also calculated on the basis of the gross value added. All these findings from the graph and also the table represent an estimate of the direct economic effects of the sector on a global scale and highlight to the economic contribution of the industry in economic growth and the job creation. Okay, now let's move to the economic analysis of the trade dryers in pharmaceutical industry. In the particular pharmaceutical industry, the overall cost of the pharmaceutical trade dryers vary widely depending on the plant type and its structure. It must be noted that the costs are generally categorized into two major types. First, the capital cost. Second, operation and maintenance, which is O&M cost. What is the capital cost and O&M? Capital cost is required for purchasing equipment and construction for the project to be commercially operable. For the O&M, it is a continuous cost that is paid over the operation period to ensure the proper operability. The cost of buying a trade dryer vary depending on the manufacturer and the quality of the dryer. The prices may fluctuate. It depends on many factors such as the size of the dryer, its capacity, and the rate drying that it can handle. Above are the example and installed dryer cost includes the purchase cost of dryer and accessories such as motor and drive for appropriate time. Indirect cost of the tray dryer can be seen as the bill of the maintenance of the dryer itself. Let me calculate this report. Tray dryers serve as an important machinery in any pharmaceutical industry. Customers have the right to consume safe and high-quality medications. However, there are advantages and disadvantages in this industry, or the tray dryer. The advantages using the tray dryer is the loading and unloading of materials can be done without losses. For the disadvantage, the tray dryers require more labor to load and unload the materials. Therefore, an appropriate safety measures have to be taken care to ensure for the smooth operation of tray dryer in the pharmaceutical industry. Thank you from us for the Group B6 for the UOL report. I hope all of you enjoy our video. Thank you.